academic title is about motets, which is 13th-century musical composition.
That's not a motet.
Ja, jetzt
Oh.
Disconnecting less. Könnte aber am Stecker liegen. The microphone. I think the microphone is disconnecting. Yeah. Okay, thanks. Yeah, it's a pleasure to be here and to give you a short insight into a project which is very different in design than what we heard so far, because it comes from, if you want, digital humanities. It's about digital corpus analysis of motets, and I'll start with a very short introduction about motets, which is a very important musical genre of the 13th century, so very old music. Important because it's, you can say it's the first polyphonic music of the Middle Ages, which generated in a written musical culture. So it allowed a new kind of complexity in terms of musical composition. And this leads to a couple of problems. So a lot of research has been done since it's such an important genre, but until now still we don't know very much about the grammar of this music. So how does it really work? I think one of the reasons is that finding out this in any manual way is really difficult. Our study is actually based on manual analysis I did many years, or throughout the last many years. But I came at a point where I had to realize that formulating any hypotheses about the grammar of this music is almost impossible. So we started a project funded by a German Research Foundation, trying to find out how this music works. That is, are there any rules, regularities? Can we find out how the composer of the 13th century conceived of these works structurally? So that you get some idea about what this music sounded like, I would like to give you two very short examples. They are rather different, but so you can just start. Another one because it's very different in style, so you get an impression of the flexibility spectrum of the music. That may suffice, yes?
Can I ask again about the problem statement? You know how it sounds, you have the written things, but you don't know how they connect. And so you don't know the grammar, or what?
Yeah, well, it's one thing to know how it does it. Okay. It's one thing to know how it sounds and how you transcribe the music, but another thing to understand how it works. Like we have, for example, for more modern music, like 19th century music, we have the theory of functional harmony. So you can label certain chords, they have a certain function within the, you know, and these kind of things we don't know. Now I have to say the next couple of slides are actually from Philippa Ovenden, who was supposed to go on here with the talk, but due to an emergency she had to decline on very short notice. So I'm a little bit improvising on the next folios, slides. Yeah, folios, there comes one. Folio. Yeah, what you can see here is one original source of that music from the 13th century. It's from the most important codex of this music. And as you can see, the notation looks kind of similar, but it's still different to the notation we know. It's the time actually where our way of writing music was being was invented in a sense. It's a bit simplified, but there are still quite a lot of differences to the way we notate music. So we work, of course, with transcriptions, and there are three basic formats. The first is the original from the 13th century. The other, you see it beneath, it's a modern edition, in this case an edition from the 70s or 80s by Hans Tischler. And the third version, of course, is our digital transcription. It doesn't show correctly here, which is a music XML file. We use music XML because there is one analysis tool by Michael Cuthbert called Music 21, which we use as the basis tool for our music analyses. The notation, however, contains some elements which have certain ambiguities. It's not certain whether we don't completely understand the notation of the 13th century or whether these ambiguities already existed in the 13th century. But anyway, there are some ambiguities. Here's an example. These three notes on the left can be transcribed in 6 rhythmical versions, as you can see on the right side. At the same time, that is not such a big problem because these ambiguities mostly occur with very short note values and don't change so much with the harmonics. But it's important to know that we need some flexibility to deal with these kind of variants. We developed an annotation system which is included in the music XML files that allows us to identify such places of ambiguity and also of problems of transmission. So we define the types of variants, like for example the first is rhythm, duration, the next is S for the source, in this case the addition by Hans Tischler, and N refers to what is really notated in the medieval manuscript. S and B here stand for note values called semi-brevis, semi-brevis, and brevis. Yeah, and so we can, if we analyze these in an automatic way, we can always see where places of ambiguity, places of problematic transmissions are, and so on. And at this point, I give over to Robert.
Thank you. I will now speak briefly about the formalization we need for this. Compared to the stuff we heard today, it's probably not so complex, but nonetheless important. One major goal is, of course, to compare musical structures, and that's why we need to model these musical objects you see down below. And one important thing is that we are actually referring to contemporary sources from the 13th century. And we come to that later. We start with pitches, it's quite simple. We do this by taking a subset of the natural numbers, and we assign a 0 to the lowest voice, to the lowest pitch, sorry. and an n, which is depending on the actual range, to the highest pitch. That's an example range, and so that would be the 0 because it's the lowest pitch. And then you go, as we say in musical terms, chromatically, so ascendingly step by step to the highest pitch, which would be in this case a 14. And then we can go one step further and we can model so-called intervals, and that's the distance between two pitches. And you can describe this by this mathematical function. It's just the difference between two pitches, and because we do not want to differentiate the order, we do it this way. And after that, we also need a classification, which is denoted by capital I. And it's important to note that this is actually a partition, so there are no intersections between the groups of interval categories. In this table, you can see two of these categorizations from the 13th century. In the column on the very left, you can see the encoding in natural numbers. And then here are the labels which are actually used in the contemporary sources. We have two major categories, that's concordances and discordance. It's a description of the quality of the intervals. And then you have subcategories. In the next step, we take a set of simultaneously sounding pitches, which we call a sonority, which are k-voice, so that is referring to the amount of pitches. And the procedure is as follows. You order the pitches ascendingly, and then you just calculate every possible interval. But of course, we do not need the interval from one pitch to itself because it's always 0, so that's not important. And we also do not need both of the combination because it's always the same. And in the end, we can write a sonority, so simultaneously sounding pitches, as a vector, depending on the number of voices. And here you can see the encodings of pitches of our example, and that would be the vector of intervals. And in the next step, we apply the classifier function, as you can see above, and that's just the mathematical or formal description of choosing the right row. And at the end of the procedure, you get these labeled for this example sonority, and that's what we call a base class. And it's just a shorthand for every possible sonority when you take these interval categories. And if they have the same label, they are structurally equivalent. So that's the idea. And that enables us to compare musical structures. And why is this important? Because when we look at this example, you can see that these look quite similar, but in fact when you do the procedure as described before, they do not have the same base class. And that's actually, that makes differences in the harmonic analysis. And now we add a second layer of abstraction, which is the important part because Frannk explained that we already have harmonic theories, but they are implicit in the terms or in the jargon, and this approach enables us to make it more flexible because in the first step we derive every possible, structurally possible base class, which is containing the sonorities as described before, and then we can cluster them into a meta-categorization, and that's the sonority types I was speaking of, and of course you can do this more abstract or more concrete, and that's one research question, which is the right amount of abstraction of the approach or analyses. And yeah, it's a double abstraction if you would describe it that way, and it enables us to have a flexible meta-categorization. And important to notice again that these base classes depend on the choice of the music theoretical source. like I've explained before, and there's no implicit harmonic interpretation which we need for analysis. And that's the basic formal part of the computational part which follows. Thank you.
Super.
Thank you, yes.
Thank you.